Welcome to The Explainer. Today, we are taking a surprisingly fascinating journey back in time. We're going to look at a Class 1 math chapter. Now, I know exactly what you might be thinking. First grade math? Isn't that just basic counting? Well, stick with me here, because what we are actually looking at is a literal masterclass in how human beings first learn spatial awareness. It's essentially the hidden geometry of childhood, and honestly, it's brilliant.
Seriously, think about that for a second. Do you actually remember how you first learned the difference between inside and outside, or, above and below? As adults, we take these concepts completely for granted. We navigate the physical world effortlessly. But what feels like basic common sense to us right now was once this complex, totally abstract set of rules that our brains had to actively decode. We literally had to map our physical world before we could ever hope to add or subtract within it.
So, the crucial point here is understanding what educators call positional words. These are simply terms that describe where objects are in relation to each other, and they form the absolute foundational building blocks of spatial awareness and early math. What we're about to see in this curriculum is how this highly academic, cognitive framework is brilliantly disguised to a child as pure, unadulterated play.
Section 1. Learning through play.
Educators know you can't exactly hand a young child a dictionary of spatial terms, right? You need an imaginative hook. So meet our narrative anchor, the furry cat. This isn't just some cute drawing to take up space. This recurring character is a really clever pedagogical tool. By giving the students a protagonist to follow, the curriculum grounds all those abstract spatial concepts into a totally relatable adventure. The child doesn't think they're learning geometry, they're just following their buddy, the furry cat, as it jumps on a hat or hides under a striped mat.
Section 2. The Furry Cat Poem.
To build an actual functional lesson, educators leverage specific poetic devices, mostly using rhythm and rhyme, to aid cognitive retention. The poem starts off with this really engaging hook. Looking, looking, looking. Looking for my furry cat. Are you sleeping under my bed? By reading this aloud, children aren't just hearing a story. They're naturally and playfully introduced to positional words like under. The storytelling beautifully frames the spatial vocabulary as a fun game of hide and seek rather than some rigid vocabulary lesson. Next up, the cat escapes the house, runs right past the kids, and then triumphantly sits up high. This visual narrative prompts children to naturally search for the cat on the page. And the beauty of it is, without even realizing they're doing math, the students are naturally formulating the concepts of being outside the house or sitting on the window shed.
Section 3. Spotting positional words.
The lesson then smoothly shifts from rhythmic poetry to guided observation. The curriculum cleverly asks the students to observe the cat's behavior to contrast opposing concepts. On one hand, we have the cat happily scratching at the bottom of a glass jar. Then, right next to it, the cat is perched way up high, playing on the top of a red car. Top versus bottom. By placing these contrasting scenarios right next to each other, the child's brain learns to categorize spatial opposites.
It's actually amazing to summarize the foundational spatial pairs these young students are digesting. They are learning inside versus outside, above versus below, top versus bottom, far versus near, and the whole shebang is entirely woven into this single playful adventure of a mischievous white cat. It is a highly efficient way of teaching what will eventually become the X, Y, and Z axes of complex geometry.
Section 4. Real-world math games.
Okay, understanding a drawing is one thing, but living it is entirely another. The pedagogy transitions into practical application by prompting children to literally get out of their seats. The book actively instructs the teacher to have the children interact with their actual classroom environment. They're told to look for a white chalk hidden near the board and under the table. The text outlines this specific hide-and-seek game. First, you divide the class into two teams. Second, hide everyday objects like that white chalk or maybe a red ball. Third, and this is absolutely crucial, the children themselves have to give verbal instructions to the other team using those positional words. They have to tell their peers to look outside the classroom and under the tree. It forces kids to actively speak and apply their new spatial vocabulary in three-dimensional space. And then the curriculum kind of breaks the fourth wall, bringing the math directly into the child's home life. It poses a think and answer question. Where do you put your shoes? Inside or outside the room? This brilliantly connects academic vocabulary to their daily habits. It teaches them that math isn't just something that happens on a chalkboard, it's literally how they organize their own lives. It follows up with another highly relatable question from the source material. Where do you throw the garbage, inside or outside the dustbin? I love this because it reinforces that spatial reasoning is a tool for navigating everyday life. And honestly, it's maybe a gentle reminder for some basic household chores too.
Section 5. Before and After.
Now, this represents the final, slightly more advanced cognitive leap the chapter asks the students to make. So far, we've been dealing entirely with physical 3D space, up, down, inside, outside. But now, the curriculum transitions the students toward linear order and sequencing. Understanding what is physically next to something is evolving into understanding what comes temporally or sequentially before or after something. To do this, the chapter introduces a train with several bogies, or cars. The instructions ask the children to find the red bogie. Then, they must fill the bogies before the red one with blue color and the bogies after the red one with orange color. This coloring activity is a total stroke of genius. Before and after on a train sequence is the exact foundational logic a child is going to need later to understand number lines. 3 comes before 4, 5 comes after 4. It all starts right here with coloring train cars.
It really leaves you wondering, doesn't it? How much hidden math do we navigate every single day without even realizing it? We learned the complex geometry of our physical world by chasing imaginary furry cats and coloring train cars. So, next time you grab your keys from inside your bag or park your car under a tree, take a moment to appreciate the complex spatial logic you built as a child. Thank you so much for joining me for this explainer, and keep looking for the hidden math in your daily life.